Okay, guys. So switching, this is the topic which we are going to discuss today. Switching. So remember, guys, so most of the work for network engineer will be on switching, not on the routing. First point. Remember, guys.
Switching.
Switching will be having more work rather than routing
Okay.
for network engineers, because the routing one time we are doing, we not do every time. Correct.
Yes.
See, your switchings can be done. So only, especially I'm talking about the routing. See, your routing will be done so only one time, right? So every day you will not go and configure OSPF, VHR, RIP, right?
Just once it is done, it's set up.
See,
That's
once
it,
the
it'll be
communication is happening, so with two routers communication is happening, you are running organizations, say this is my HP company, this is your Dell. Okay, they'll communicate with each other. Once this is done. So what about the switches where you are going to connect a lot of devices? Individual devices we are going to connect, right? Like this. So here you will be having a lot of work. So that the result, so switch is a concept where you are going to do a lot of work in your switching. Fine. So how does switch works? So right now we are dealing with layer 2 switches, guys. Okay, remember, so we are going to discuss about layer 2 and layer 3 switches, guys, because as per the Cisco, I think 300 120 exam code, right? So they have added layer 3 as well. So previously, I think, because I think, do you remember, so I had not talked about layer 3 switches.
Layer 3, yes.
Okay, right. In
Yes.
NTT, so when I have given training to your
only L2 you have given.
Just I have given for L2. So in this, we shall discuss L3 also.
Yes.
And L3 as well as, I think, right, Ether channel. Because do you remember?
Ether channel.
That is your port channel.
Port channel. Okay.
Do you remember port channel, Ether channel?
No, that's
What, because completely you are forgot, man. I think hardly 1 month over, right?
yeah, that's almost no more than 1 month. That the month of December you completed it off. Now the month is March, almost 3 months.
3 months. It's not a big time. Huh?
Not a
See, Ether channel is simple. Just we are making bundling.
Oh, this was that port all together. We are making it as one single.
Yes, single pipe. One bandwidth. Say, as example, this is 1 gig. Means totally, if you make it Ether channeling bundling, so what happened? It will become your 4 gig. This is called Ether channeling. So Ether channeling, what I have explained into your team, that is layer 2 Ether channeling. We can also do for your layer 3 as well. Layer 3 Ether channeling as well. That also we also do the lab. So this I have not explained in NTT.
Yes.
Okay, for company. So this also we can make it bundle. This is your layer 3, right? Your router is your layer 3.
Yes, that is at layer 3.
Okay.
So even for switches also, as well as for the router to router also we can do it.
Yes. So this lab, so which I not explain. Okay, so in NTT, so this I will explain. For I think your team, your friends, I think Rakesh, Swati, I think I don't know.
Yes, for we are at batch 2. I think
Batch
so
2, right?
Batch 1, batch 2 was the morning 10 to 1 and again 2 to 5.
For them I have not explained. Okay, because so here we are also going to discuss your layer 2 as well as layer 3 Ether channeling. Okay, And one more good thing is, guys, so even I'm going to discuss your HSRP. HSRP. So hot standby redundancy protocol. Hot standby redundancy protocol. So this also I shall discuss. Anyhow, so I'm writing the content before I could start the training. So let me write it on the notepad, because guys, so you should know, guys, what are the topics I'm going to discuss. This is not, this is actually CCNA as per the Cisco, guys. What this training I'm giving to you.
No, the session from today.
Yeah. No, everything.
Everything, but this is the very important topic.
Yeah, very important topic. So because this is where we'll be having a lot of work in the company. Because routing, every time, what is the job of the routing? Just to make them communication between the two different network.
Yes.
Correct. So whereas these one switching parts will be having every day a lot of work. So every day you need to do job. Removing trunking is happening. So we need to add some clients. Okay, we need to add some new network, remove the network, delete the network. Okay, so right now we'll do, we'll going to discuss, let's say, I'll type it down, the content. Okay.
Yes.
So rather than I'll type this thing. So right now we'll do the virtual switching content. You can see, right? So virtual LAN, I think right? This is called VLANs.
Yes.
Right, so that we shall discuss. And verification, the lab. Verification of VLAN. And third one is, what is trunking, Vikas?
Don't ask.
Huh?
Don't ask me that. I don't want to Google it. I will just learn it from the scratch.
You don't want to Google?
I don't want to Google it. That's
Okay.
I have to learn it from the scratch.
So this week Saturday, guys. So one more topics which I'm missing to you guys. Okay, as I told you that. So that one also I want to cover it. That is IPv6. I think in the entity also I have not explained, right? To your team members in your company. Okay, so IPv6. In IPv6, the theory part I will explain. So then will the lab also will do. So what are the lab we can do in IPv6? We can do your static routing. Then you will also do the RIP. We'll also do your EIGRP. We'll also do the OSPF. So using IPv6.
1, 2, 3, 4 protocols.
Yeah. And BGP also we can do it, but it takes time, lot of time. So I think this I want to complete in just in one day. So
it's in a lab, right?
Yeah, it is a lab, because these are not explained. It is there. It is one of the part of the CCNA. That is latest CCNA. So they hand you to IPv6. So previously, so when I learned that there is just they used to explain only theory part.
Okay.
So only they explain only theory part. So now they ask, now they are giving configurations based on your routing protocol using IPv6.
Oh.
Yeah. So it is, as you know, it is 128-bit, right?
Yes, it's a 128-bit.
So right now, so what are the lab we did till now? That is your IPv4.
IPv4.
Okay, that is your 32-bit.
Yes.
32-bit. So we'll also do lab for this one. So native VLAN we should discuss, then inter
networking.
VLAN routing. Intel VLAN routing also will do. And inter VLAN routing, so we have using separate gateway. Many topics are not explained in NTT because they want customized content. They don't want everything. They want which is required for their employees.
Yes, that's those people like weird kind of thing.
So inter VLAN routing, so using sub interface. Any idea about sub interface, Vikas? Remember?
Subs in general terms means a backup kind of thing on more interface you're just taking it out. Like instead of a main route you're taking a short route as well sometimes. That is how the sub interface.
Sorry, can you come again?
No, instead of taking it a main route, if the main path will be there, instead of that again you are taking a sub path for this thing. If it is the traffic is more, we'll take a sub path. So that is how subway kind of thing. A similar kind of thing. It's a sub interface. If it is a more the traffic is there, it creates a sub interface and we can just getting connected with it.
And what is STP?
Spanning tree protocol. That's it.
Okay, we'll do the spanning tree as well. And spanning tree, like selection of the root bridge. Okay, your STP, say selection of root bridge.
Yes. Bridging.
And then we'll also discuss your per VLAN STP. That is will call PVST, per VLAN spanning tree protocol. Okay, so then we should discuss the Ether channel. Okay, so the Ether channel, so we shall discuss your L2 as well as L3 Ether channeling. And also discuss about spanning tree port fast. Also, then 15th one we'll discuss BPDU. Any idea of BPDU? No.
No.
And also discuss rapid spanning tree protocol.
Is it a 1-year course, Touch?
Which one?
This one, CCNA.
1 year? No, man. It's a just for the corporate training. CCNA is just they'll train for maximum 10 days. For the retail training, if you go for any training centers, because in here also we will take maximum 3 weeks. Your batch should be completed in March 3rd as per my schedule. So now, due to some gaps, I think you have taken 4 days gap and some 1 day gap, and I think 1 day we have cancelled. The 1 week is gone. So the reason, so our this training is still continuing. By seeing the content, you are telling content is huge.
Yes.
Okay, one more thing is, so MST also is there. So let's see if it is possible, MST CCNP, CCNP topic. If possible, I'll explain that one also.
Yes.
Okay, so then another one is also discuss CDP and LLDP, Cisco Discovery Protocol, and later Training protocol. Then we'll also discuss AAA authentication. So using TACAs. You heard about this guy? We should discuss TACAs plus and radius. This is very important, guys. Okay. So last topic, so will be hang HSRP, RP, VRRP, GLBP. So I think it is CCNP. So we should discuss only HSRP. So VRRP, GLBP. So I don't want to explain. That is CCNP topics. But as per the CCNA, what I've seen the syllabus last week. So these are topics which they had it. The content is so this will take guys as per this thing. If you check, I think these topics so can be completed in 5 days maximum.
Okay.
5 days we can complete this all topic.
Hmm.
And today we'll do the basic configuration of us. So using a
Yes.
spanning tree, putting your STP. And very good thing is, guys, spanning tree is quite very interesting, especially your switching. Switch
Around stock
is very interesting to learn. That we should discuss. Okay.
Yes.
Okay. So these are the topics which I'm going to discuss, guys. So please remember, very important topics. All. The first topic, what I'm going to discuss. That is we'll go some theory part. Theory part, I'll go a little bit faster, guys. I think you can able to understand because switching basic I explained already for you. So here, Pawan, you can able to follow, right?
Yes, sir. Yes, sir.
Yeah. So first understand, guys, you're switching right now, or you dealing with your layer 2. Remember, guys, layer 2 means it's talking about data link layer.
Yes.
It works, switch will work in data link layer. So one more thing, remember, now latest one, layer 3 switches also available. That is in work in your network layer. That is your layer 3 switch. What is the difference between these two means in layer 3 switches, we can do both routing and switching.
Now one single device.
In one single box, we can do routing and switching. Whereas this in layer 2, we can do only switching. Remember, guys, don't get confused. So in the Cisco packet tracer, I think you can see multi-layer switches. So multi-layer switches. That I'll show you that multi-layer switches. So we can do your routing as well as switching. Both we can do it. I think all of you installed, right? Pawan, did you install the packet tracer, right?
Yes, sir.
Yeah. So let's discuss, guys. So switching services, we can see what is talking about. Unlike brief softwares, it create manage filtering the switching applications, specific integrated circuit, that is a ACIC. Lead switches are bridge are faster than router. I think I told you, right? The switches are quite very faster than your router because they don't take time to look at the network layer header informations. Means, so switch is going to work based on your frames. And direct it to MAC to your physical address. That is your MAC address. Correct. So it's look at the frame hardware address before deciding either it will forward the frame or drop the frame. So if anyone, so as you know that it works, it doesn't understand the IP address. Remember, we cannot give the IP address, right, for this switch.
Yes.
Right. So example, this is my PC. So example, this is my MAC address. Say AAA dot BCX012 some X IP address. This is my PCA. So what it does means, so what is trying to talk about? Suppose example, this PC to PC, they want to communicate. For example, this is BBXYZ, some IP address. This is my B. So now, when these two guys want to communicate, as you know that, okay, switch what it will maintain, guys? What switch will maintain?
MAC address.
MAC table. On, just pay attention here.
Yes, sir. Yes, sir.
For you, this is the first time, right?
Yeah.
Okay. So let me explain in the new guys. I think rather than explaining here, it takes a lot of space to write.
Okay.
So first understand, guys, how switch will work, guys. First understand. So this is my switch. I'm talking about layer 2 switches, guys. This is my MAC table. So it maintained the MAC table. What it contains? Okay, MAC address and interface name. These two parameters going to maintain. Say example, so this is my PC which I have connected here. So here also I will connect PC. So let's say these three PCs, PCA, B, C. So we'll give some MAC addressing for these guys. So example, this guy is AA and this guy is BB. This is CC. What happened? So, you know, your layer 2 switches, when the PCA want to communicate with PCB, what it does mean, it broadcasts to all the active ports first time. Okay, it will read this MAC address. Okay, AA with the port number. So this is the port number, guys. So example is Fortinet 0/0. Okay, and this is Fortinet 0/1, and this is Fortinet 0/2. Okay, it will add. So here interface name Fortinet 0/0 I have learned. So this guy want to communicate with this guy, because this MAC address is not available in the MAC entry table yet. Okay, so what it does means, first time it will broadcast. First time it does the broadcasting. So when broadcasting, so this guy will respond. Okay, so this guy, so he want to communicate, which will be tags. I want to communicate with the BB. I don't know, because you know switch doesn't know who is BB available in my MAC table. No, because so before MAC table is empty. When it is empty, it broadcasts every time. If anyone want to communicate with any guy, okay, this guy want to communicate this guy, or this guy want to communicate with this guy. So first time what it does, it broadcasts every time. Okay, it will make an entry. BB MAC address, which has learned from Fortinet 1, and CC also I have learned the Fortinet 0/2. Okay, now what happened? So next time again, A want to communicate with C. Okay, this time it will not do the broadcasting. Before broadcasting, it will check the MAC table, whether this C is available in my MAC table. So directly it will send. It sends directly to that port. Means we can unnecessary broadcast storm we can avoid. It also minimize your bandwidth, and your network performance will increase. Correct?
Can you explain that once again, Tash? How it is broadcasting directly?
See, before empty, first it will broadcast every time, because you know,
Correct.
because it was empty previously. You don't have any MAC addresses. This is my MAC table. So empty, what happened? So when this guy want to communicate, so let's say I'll remove this.
Yeah, once that
The first time,
first time when it communicates with
yes,
all the
it will
ports, second
broadcast
time,
all this thing.
yeah.
That's it.
First time it will empty because it try to broadcast to all the active ports. If there no port connected, it will not do the broadcasting. Only for the active ports. So now these guys, once they have done the broadcast, so this guy will respond. Okay, fine. So he want to communicate with me. This is a MAC address. This is the MAC address of my PC. So it will make an entry in the MAC table. Again, same thing. Next time, if A want to communicate with C, okay, this time again it does the broadcasting to all. It will make an entry in the MAC table.
Yes.
Okay, now if C want to communicate back to PCA, then before broadcasting, it will see whether I know this guy available in my MAC table. Yes, it is available. So directly it will send. Directly it will send. Because of this reason, your switch is fast device.
Yes. Faster than routing.
Router.
Yes.
This is faster than your router. So now, how switch and bridge learn? Okay, the MAC addressing. So let's rather than this one, he has explained the different way. Same example what I explained to you. So let's say example switch features unknown unicast address, broadcast frame, multicast frame. There are three conditions in which the switch will flood the frame out all the ports except the ports from which it has been come. Okay, except the port which it hasn't come, it will send to all. This is the basic things what is going to work. So let's say, so same example what I want to explain here. So previously we can see, okay, your MAC address is empty. As you know, MAC address table is empty now. So all the PCs, PC A, B, C, D, 4 PC, it has been.
Raj, are you writing something?
No, I am not writing.
Okay.
Just explaining, buddy.
Explaining.
Explaining on.
Yeah, I'm not writing anything.
Yeah.
So now see, so now I'm writing now. See, as per station A, station A send the frame to the station C. Okay, this is my station A, want to send to the station C. So what it does means it will make an entry with the MAC address. MAC address of this guy, right? It is correct, right? 111. Okay, what happened? When the MAC table is empty, it broadcasts to all. Okay, switch cache the MAC address of the station A. Okay, and with the port number Ethernet 0. It will make an entry with the Ethernet 0. See, we can see, right? And with the MAC address. Learn from the source address of the data frame. The frame send the station A to station C. It is flooded out all the port except the port by himself. Unknown unicast are flooded. Means it will send to all. Okay, means it will send to all. You can see, right, arrow mark. It will send to this guy, it will send to this guy, it will send to this guy.
So A will send this one.
Yeah, it will
to B, C, and D.
Yeah, it will see from station A to station C. It will flood out all the ports except the port E0, except the port which has received. It will send all the ports, port E2, E1, E3. The port which has received, it will send to all the active ports. So each port is connected to PC C, B, and D. So this is called your unknown unicast are flooded. So now what happened? Now this time you can see here. So station D send the frame to the station D. Now station D. So this guy has sent to your station C. Now here what happened? So here what happened? Switch cached all that, the same thing, because again it will make an entry. Okay, I learned from this Ethernet port E3 port number with this MAC address. Right? So again, the frame from the station D sent flooded to all the active ports. Again, this guy will send. When this guy has sent to this guy, okay, it will broadcast to all.
Except E3.
Except E3.
Hmm.
Okay.
Got it.
Now next. So filtering of the frame. Now what happened? Station A send the frame to the station C now. Again. Now this guy want to communicate with this guy. Now what happened? Destination is known. How frame not flooded this time? Because in
I've
the
already
MAC
learned, right?
already learned the MAC address.
MAC address.
Because I know these guys. So why I should flood? Okay, flooding will be stopped. Directly it will send. So example as simple as these guys, because previously I don't know your names, right? I can remember now. Got it. It takes time.
Yes.
It takes time for me to learn your MAC address. Pawan, Sarik, Vikas. Right. Even the previous batch, in the Vikas batch, I think Swati, Rakesh, Saundarya, and a lot of people are there, right?
Yes.
So in your batch, so still I can remember, because in the MAC table already have read. Because if I don't know, it's like a teacher guys, when the teacher enter into the class first day, because teacher doesn't know what is the name of the students in the day one.
Yes. They'll ask us to tell
Means-
their names.
Yeah.
Stand up. Tell your
Even
names.
even that if they explain the name also, so they can't understand. So it takes time to the
Time to
teachers to
teach.
build up their MAC table.
Yes.
Okay, first how they are going to teach? They send broadcasting.
That is a broadcast.
That is broadcast, because madam, he or she don't know the student's name. Directly she keep on explaining. Even the question also she cannot ask. Right. She can ask based on the identification, like blue color t-shirt, red color, pink color, orange color t-shirt. Please answer me this. So after a few days, once they come to know all the name of the students in the class, okay, directly he or she will ask the questions. So please, Pawan, so please tell me what is this? How does your switch is going to work? It takes time, right? Same concept here. So now same thing here. So in this scenario, so we can see what is talking about. Station D send the broadcast or multicast frame. Okay, broadcast multicast frame are flooded to all the ports other than the originating port. Okay, once station D send your multicast frame or broadcast frame, it will send to all, except it has been originated. Okay. So this is a basic function of this one, guys. So let's discuss forwarding and filtering decision. When the frame arrives to the switch interface, destination hardware is compared to the forward to the filter of your MAC address. First, before checking flooding, whether I know this guy name or not, it will not flood directly. First, it will check whether I know his name or not. And one more thing is, if the destination hardware address is known, in the list address, the frame send out only to the correct exit interface. Understood, guys?
No.
See the previous slide. Let me go back. See, if you know, okay, I want to communicate to this guy. Station is sent to the want to communicate with the station C. Okay, this guy want to communicate with your station C. What happened now? So because the switch already
Learned all
learned
those things.
all the MAC address.
MAC address, and he knows the destination, so he will send it directly to the
Destination. Okay, because directly it will send.
Yes.
E2. Okay, fine. I know E2. So this guy, this MAC address, okay, it is available in my it is connected to my Ethernet interface 2. Okay, it will send to this exit. Please exit from here. I don't want to broadcast to other guy because I know this guy which is available in my MAC table. Understood, guys?
Yes.
The same thing he's talking about now, broadcast multicast framing. So here also we can see, guys, same thing previously. So we can see. So learning the MAC address, the first MAC, switch 1 MAC address, switch 2 MAC address, guys. So please understand here, now both are empty now. We can see PC3 MAC address. Okay, PC3 send the message to the switch 1. So switch 1, what it does, it will make an entry. You can see, right? It will make an entry here. Okay, again, it will come down. So now you tell me, so what it will make an entry here? It will make the address that is your 33, right? 33, some MAC address. Okay, and what is the interface name? So here interface name, it has learned what? Fortinet 0/13, 13, right? And what interface name it will make an entry here? Who will tell this answer? It has learned from Fortinet 24. Correct?
Yes. Sir.
Yeah. So let's see here. Can see, right?
Yes. Sir.
Right. So he has learned from this side. So now let's see the next one. So there's a one more PC. So they are connected with the MAC address of these. Okay. Now what happens? So it will send the frame here and you make an entry with the interface name with the MAC address, and then again it will send to other switch. Other switch, what it does? So this switch also, it will make an entry here. You can see with the same interface. Means this switch, this link, this interface, when you connect it from one switch to another switch, and this is called your trunk link. Remember, guys.
But could you explain it once again?
That's what I was about to say.
Okay, when you connected the two switches, guys.
Yes.
Okay.
Okay, when you connect the two switches.
Switch 1, switch 2. Okay.
Okay, this is my switch 1 and this is my switch 2. So when you connect to the two switches, and these links, these two links, okay, we'll call it as the trunk link.
Okay.
Because maybe you are running some VLANs here. For example, VLAN 10, VLAN 20. Okay, maybe you are creating VLANs like this. Both VLAN you are creating here, VLAN 10 and VLAN 20. Okay, what is the trunk link means? Trunk link will carry your multiple VLAN traffic. VLAN data also we can say VLAN traffic. This is a link. If the links go down, means what happens? There is no communication. Correct. This is the VLAN what I'm talking about. That will do the lab, guys. Today itself we'll do that lab. Basic lab. Understood? What is a trunk link? Trunk link is the link which will carry the multiple VLAN traffic, guys. Remember.
Between the switches.
Between the switches. Remember. which will carry your multiple VLAN traffic. Very important, guys. Trunking link. In the interview also, in the job also, you must know about it. Okay, so let's jump for this one, guys. So again, in the switch 2, again, they have connected one more PC. This 2 dot with their MAC address. When this guy sends, okay, it will make an entry as usual. Okay, he has come from this interface. Okay, Ethernet 0/12. Okay, again, he'll get sent to this interface. Now, this will make an entry here 2222 here. Then he learn from Ethernet 23. Correct. So this is how we are going to learn, guys. So now next, what happened here? So last slide, when this PC3 want to communicate with the 222. Who is this guy? This guy. So this guy want to communicate with this guy. So how does it going to do your communication, guys, here? Because, you know, before broadcasting or multicasting, okay, it will check the MAC table, whether I know this guy or not. Okay, yes, it is there in the interface Ethernet 23. Then what it does mean, it doesn't do the broadcasting here. Directly, it will accept this frame. Again, it will directly forward to this interface. Okay, fine. Now, Ethernet 0/24. Okay, where I have the 2 MAC addresses for this interface, because, you know, this is a trunk link. Okay, what it does means, you know, the MAC address which he want to communicate is 22. Okay, the 22 is available to my Ethernet 12. When this frame has been received, okay, from switch 1, so what it does is, what is going to do here? So, do you know this guy in your MAC table? Yes, I know which is available in my Ethernet 12. Understood, guys? Guys, all of you, guys, are you there, guys?
Yes, Taj. Yes.
Yes, sir.
You understood what I explained here?
Yes, Taj.
Yes.
Just simple as this, guys. When this guy want to communicate with this PC3 to PCC, okay, so destination is what? 222 MAC address. It will check here. So is guy is available in your MAC table? Yes, it's available. See, it's available in my Ethernet 23. So the frame will come down. Okay, destination is known. Okay, when the frame come down, this Ethernet 24 will check whether this MAC address is available in my MAC table. Yes, it's available in my Ethernet 0/12. Directly it will send. Even though you have connected other PC here, okay, maybe PC X and Y, some different MAC address, it will not send. Directly it will send. This is one of the reasons it is very fast, which is faster than your router. So let's discuss what is a loop avoidance. Okay, redundant link between the 2 switches is a very good idea because they help to prevent the network failure. Okay, you know, redundancy link is quite very important. When one links go down. So what is the meaning of redundancy? Means 2 links will be connected for the single device. So where one link go down, your other links still you can able to have the communication. That is called your redundant link. However, so they often cause more problem because the frame can be flooded down all the redundant links simultaneously to create the network looping. See, redundancy link is good, you know, when they have connected the switch 1 and switch 2. So they have connected some pieces here, the manufacturer floor controller and data center server. So they have been connected. When these guys send the frame, what it does means is going to send to this guy. From this way also it will send. It will send to this guy, again it will repeat to again here. Again it will send to this one. So this will become a loop. When you connect your redundancy link, but it is a good idea. If one links go down, still he can communicate via this. When this guy want to communicate to this, links go down. Right? This is our advantage of redundant link. Pawan, you understood, right? What is redundant link? Sorry.
Yes, sir.
Yes,
This is the-
Taj, I understood. I explained this one earlier also.
Okay, so broadcast looping, what happened, guys? So is keep on rotating, each guy will communicate to each other. So it will become the looping. So if you see this diagram, okay, so router C has been sent some broadcasting message. When this from this server, he has sent some unicast message to this router, it will send to other guy. It also send to down layer switches, and these switches will send to this, again to send to this. So it became the looping, multiple frame copies. We can see, right? This is a 1, 2, 3. They are repeating to each other.
Yes.
Right. So to avoid this problem, they have come up with a solution, that is your spanning tree protocol. Okay. So what is spanning tree protocol? So network redundancy, extremely important, because your redundancy allow network to the fault tolerance. Of course, your redundancy is quite very important. So once link's gone, it is like your plan B, plan A and plan B. If the plan A fails, your plan B, it will work. That is called redundancy link. But it is very important in network, because it will give the network performance for the fault tolerance.
This is for the spanning tree protocol you're telling, right?
Yes, this is a solution for the spanning tree. Yeah, I'm going to
Redundancy. Yeah.
Yeah. Your redundancy topology based on the switching and bridging, okay, based on your multiple broadcast multiple frame transmissions, and your MAC address database instability. So therefore, network redundancy required carefully planning and monitor your functionality. Okay, your spanning tree use in the switching network to create the loop-free network. The solution is your spanning tree protocol. So that we are going to discuss now. So what is the job of spanning tree, guys? It's very simple, guys. The spanning tree is going to do the basic, I'll tell you, the basic characteristic of the spanning tree protocol is when the two links are connected in this way. When the two links are connected, okay, one links will be blocked by default to avoid the duplication. To prevent the loop-free redundancy network topology by placing certain ports into the block state. By default, is going to block. When you connect the two switches, so example, redundancy link. This is how we are going to connect it. By default, one port will be blocked. This is called your spanning tree protocol, STP. Because why it is doing like this? So when any new update, if it has sent to these switches, example, this is my switch 1 and this is my switch 2. When this guy has sent any update, okay, he should not send it back to again. If it is a block statement, it will not send, right?
Correct.
That's the reason. So that's the reason the spanning tree by default. When you connect the two switches like this, okay, by default, your STP is going to work. By default, you need not do anything. It will work by default. By default, it's going to work. You are not going to do any configuration here. Okay, so he's talking about spanning tree protocol, residence in your.
Raj bhai, 1 minute, just go back to that slide, no, back side.
Okay.
One
Yeah.
second. No?
Hmm. So
Loop
it
free
just,
redundant network
yeah, so it's provide a loop-free redundancy network topology by placing certain ports into block
Block
state.
it.
Very simple, because if anybody asks, guys, please, these are very simple, because I used to ask in the interviews for the people. I will ask like, how does spanning tree works? Very simple answer you tell, because first you tell redundancy in the network is quite very important. Okay, so it creates some issues in some network. Okay, it will make the duplication of the frame. Remember that. Always use the technical words. Frame. Don't tell data, okay, or packets. When you are talking about the switching means, you should talk about the frames.
frames. Yes.
Remember.
But the names, the pseudo names that you have to use.
Yeah, because be carefully while answering it. Okay.
Hmm.
Now the basic characteristic of the spanning tree protocol is going to block any one of the port to avoid the loop.
So what the
Yeah, if you tell this answer is sufficient, they will understand that you have understood the spanning tree very well.
Yeah.
Yeah, and don't get tension while giving the interviews. So as you know that it works in your data link layer. Remember, spanning tree is also going to work in your data link layer. So Ethernet bit switch can be implemented in 802.1d. Spanning tree protocol used for the spanning tree algorithm to construct the loop-free network. It uses the algorithm, spanning tree algorithm. By default, when you connect two switches, by default is going to block any one of the port. That lab will do it right now. We'll take small break for 10 minutes. We'll come back when we'll do the switching lab.
Yes.
Very
Okay.
interesting, guys, because for you, I'm teaching you because you should be ready with the CCNA global certification exam, guys.
Yes.
Just try to plan this exam, because in April and May we are expecting a lot of openings, because company people this time they're going to hire only the technically good guys. Your knowledge is quite very important. Okay, guys, space is quite very important for topic here. Spanning tree port states. Spanning tree state each port to the several different states. Okay, you have the block states, listening state, learning state, forwarding state, and receiving state. So now how this guys is going to work? Let's say, so I'll be connecting the two switches. So let's say I'll connect with these two switches. So as you know that by default is going to, sorry, this is one problem here. So let's say I will connect like this. So as you know that when you run this is my switch 1, this is my switch 2. So by default, I told you spanning tree will work, right, in your catalyst switches. Remember, right now the Cisco, we are talking about the Cisco catalyst switches, or we can say the CAT switches, that is 2000 series switches. So one link will be blocked. To block the link, okay, so suppose if this link is blocked, say example, what happened, by default is going to block. What happened when these links also got blocked? What happened when these links also got blocked? This will come up, right, automatically?
Yeah, if one is blocked, other will come up, right?
Come up. So Maximum age, if this guy is not receiving any update within 20 seconds, okay, within 20 seconds, what happened? Is going to block. Then again, it try to listening to make this up, it take another 15 seconds. Listening, forwarding delay 15 seconds. Okay, next thing is learning. Learning also, it takes another 15 seconds. And then it will forward. Then it will forward your frames. Means total how many seconds? 50 seconds to come up these links. Very simple lab, because we just connect two switches, go to this interface, shut down that interface. So it will take these 50 seconds to come up. Very simple lab. So now what happens in the real time, guys? 50 seconds is not acceptable. Is almost 1 minute, right?
Near to 1 minute.
Near to 1 minute. In the production network, okay, in the real time is not acceptable.
Even if it is a 1 second blocks also, it's completely gone.
It's not acceptable. Okay, for the solution, this one is so again they have come up here PVST, okay, RSTP and MST. Okay, per VLAN span entry protocol, rapid span entry protocol, and multi-instance span entry protocol. So these are the solutions. Okay, especially this rapid span entry protocol. So which is going to avoid this, I think these two. So it come up in 30 seconds. These two will avoid, just that it will come in 20 seconds. So 20 seconds it will come up. This is the solution, guys. Okay, so selection of the root bridge and non-root bridge, guys. This I'll show you directly in the lab. Okay, so here I'll tell you some of the basic theory part. Then we'll take the break and then we'll come back and start doing the lab. See, first understand, when the switch turned on, span entry algorithm are used to identify the root bridge. So BPDU send out to all your bridge ID.
Wait, what is it? BPDU?
So bridge protocol data unit.
Bridge protocol.
BID.
Okay.
Bridge protocol data unit. See, keep alive message. So every 2 seconds, so they will send the BPDU message. So every 2 seconds. Okay. So but the default priority for all the switches are 32,768. This is the default priority. What is the root bridge? Okay, root bridge. Okay, this is your non-root bridge. Root bridge is nothing but your team leader. When the switch first time start, it assumes that it is a root switch and send the BPDU. This BPDU contains your bridge ID. What is the bridge ID? Bridge ID is your 32,768. By default, all the switches has got the same BPDU number, right? Guys, first understand, I'll tell you this one. In this BPDU message, they will keep on sending every 2 seconds. In this message, it contains your bridge ID. It contains your bridge ID. So bridge ID is same for all the switches. This is also Cisco device, and this is also Cisco device. The bridge, your default priority number for all the switches is Cisco switches is 32,768, and this guy also got 32,768. Then who will become the root bridge now? All the switches decide that the root bridge with the smallest bridge ID value became the root bridge.
Root bridge.
Smallest. So if it is the same, what happened? If it is the same, what happened? Then we can reduce by giving the value. So example, I want to make these switches as the root bridge. We can give 4096. Okay, it will become reduced to 4096 means this guy will become your root bridge. Means selection of the team leader. Because if you go for any data center, we can find most of the switches in your rack. In your rack, we can see the switches. In the switches, we will be connecting many servers. This all this one, guys, switches like this. Okay, and this one is connected for one more rack. In this rack, it is connected for your servers, rack bound servers or C series servers or your blade servers, and full with the blade, with the half with the blade. And because it is there, I think if you go in 12th floor in NTT, so they have got very good racks.
Racks.
Yeah, you can see in 12th floor.
No, we are also sitting at 12th floor only, touch in the office.
Just go and visit. I think there is there. We can check there. Understood, guys?
Yes, sir.
Yeah.
Pawan, any questions here? Understood?
No, sir, I understand, sir. Yeah, అర్థమవుతుంది. But new topic కదా కొంచెం.
వీళ్ళకి కూడా న్యూ టాపిక్.
Yeah, yes, sir, yes, sir.
వీళ్ళకి కూడా చెప్పలేదు వీళ్ళకి.
Okay, okay, sir.
ఫస్ట్ టైం.
Okay, sir, okay.
అంటే వికాస్ కి కొంచెం చెప్పాను, ఒకసారి ట్రైనింగ్ ఇచ్చాను వికాస్ టీమ్ కి, ఎన్టీటీ వాళ్ళకి కొంచెం ఐడియా ఉంది, దానికోసమే అడుగుతున్నాను వికాస్ కి.
Yes, sir, yes, sir, I understand.
ఎందుకంటే 3 months అయిపోయింది వాళ్ళకి ట్రైనింగ్ ఇచ్చి.
Okay.
ఇంకా
one question you said, right? All bridges see these and decide the bridge with a smaller bid value will be the root bridge.
Yes.
So how will be the bidding? The smallest bridge value we decide.
We can configure that. We can change that value.
Oh, we can change the value. Okay, okay.
Yeah, we can change this value.
This 32,768, we can make it as 32,750 also.
Yes, we can reduce by this value. That will become around, I think, 26.
4,096 we have to go.
Yeah, this is a default value we should give. I'll show you this in the lab.
Okay.
Okay.
So spanning tree terms is there, guys. So we have the terms of spanning tree. Okay, a bridge protocol data unit. All the switches exchange information to use in the selection of the root bridge. Bridge ID. Bridge ID is how STP keep track of all the switches in the network. It determines the combination of the root priority. By default, all the switches are same, and it is based on your MAC address. Okay, it also depending upon your MAC address. Okay, right now we're dealing with the switch priority. Root bridge. The lowest root bridge ID will become the root bridge in the network. Non-root bridge, the ID which is not a non-root bridge. And what is the root port? Root port is always the link directly connected to the root bridge or shortest path to the root. Okay, so which is connected directly to the root bridge, to the team leader, directly connected. Say this is my 2 switches. So when these 2 switches are connected trunk link, okay, so now this guy who will become the root bridge. So so once links will be go down, okay, and so this is called your root port, this port which is connected directly. So now designated port, so root port is always directly connected to the root bridge. So example, this is my root bridge, this is my non-root bridge. So only this guy can forward any updates, not this guy. If more than one link is connected to the root bridge, then the port cost is determined by checking the bandwidth. So what happened? So maybe I think you can connect one more, right? And we can connect one more also. Now what
So
happened?
whatever the bandwidth is running on the entire switch, that will be the
Yes, not entire thing. It will check the bandwidth. Say example, okay. So this is my 1 gig. This is my 1 gig. And this is my, say example, 500 Mbps. And this is 100 Mbps. Now, who is the root bridge now?
100 Mbps, sorry, 1 gig would be the
1 gig would be the this one.
Means this guy will become the root bridge.
bandwidth.
Root bridge now.
Higher the bandwidth or lower the BID.
Yes, bridge ID, remember.
That's what bridge ID is.
Yeah. What if you make it bundling? Bundling is simple, guys. Like if you have sticks, right? Okay, sticks, all the sticks we are making bundling with
Yes,
the tag.
like a thread.
Yes, thread. Same thing,
Yeah.
bundling. That is called, we'll call ether channel.
Ether channel.
Ether channel or port channel, both are same.
Hmm.
Remember, we cannot do the bundling ether channeling if the link speed is different. Remember, this is quite very important.
Hmm.
We cannot do the bundling. The link should be same. As simple as the gas, because you know, when you want to make bundling, so one stick is big, one stick is small, one stick is so big. Can you make it a bundle?
No. Should be of same.
It should be same speed, right? All the links should be same. So link speed, say example, this is 1 gig. So then totally, if you make it bundle, all the 4 links will become your 4 gig. So now what is designated port? Designated port 1, which has got determined the having the best lowest cost. Okay, lowest cost designated will mark as a forwarding port. Means this guy will become your DP, designated port. Okay, non-designated port 1, which has got the highest cost, and this guy will be these guys people will become your non-designated ports. Means they can't forward it. Only this guy can forward because the cost is very less. Blocking port is frame which cannot be forwarded in order to prevent the loop. As you told, this is the blocking port which I told you, right? So blocking port is a port that will not forward the frames. Any questions, guys? Understood, right?
Yes.
Okay, so can we take the break now? Then we jump for the lab now.
Yeah,
Yes,
sure.
sir.
Okay,
Yeah.
so let me explain this one. Guys, what is this, guys? Who is the root bridge here? Spanning tree. So what is talking about? Who is the root bridge here? Who is the root bridge?
Switch X would be the
Which X, yeah.
Why? And both priority are same, right?
yes.
Then how
Like
how these guys
Yes, sir.
became root bridge?
No, yeah, everything is same.
Then how this guy will become root bridge?
it depends on the bridge priority and the MAC address.
Okay, lowest bridge ID. Who is the lowest bridge ID?
X.
How?
No,
It's
where
not
is
same,
the
right?
bridge ID?
Same, right?
It's
Same.
bridge ID.
Default
Yes.
property priority is
He
same.
is asking question here in this example. Which switch has got the lowest bridge ID?
Both are
have the
same, so we have to manually have to assign the road bridge.
we have
Okay.
to reduce.
That is okay, because okay. So because now as per this thing, so which has got the lowest MAC address?
Lowest
Okay.
yes.
This is the highest, right?
You have to say this. The lowest MAC address.
It also
one.
see it
Yeah,
also
this is two,
see
this is
the
one.
it also see the cost.
First when I saw, I thought it was 6,000. So I was telling X.
it also see the lowest cost as well. If the same thing are there.
Hmm.
Your bridge ID, what it will contain? Your bridge ID contain your bridge priority and MAC address. Who will carry this bridge ID? Your BPDU,
BPD.
bridge protocol data unit. So it sends every 2 seconds.
Hmm.
Every 2 seconds, BPDU will exchange the information. It is nothing but a guess. In the classroom, if you, I think you might know, some students they'll sleep.
Hmm.
While doing some training, some teaching.
Yeah, like me, Taj, sometimes.
Okay.
No, you are sleeping, huh?
Sometimes I will sleep off, not here. Before I used to sleep.
Now all the informations are all coming out. That's the
No, I'm telling the fact. Why should I lie? Before, no, before in the class, I used to sleep up on the bench only.
not only you, even we also did the same thing.
Yeah, backbencher.
You are also backbencher, Pawan.
Yeah, 100%. I like that place only.
You know, and I used to get properly with the this one, what do you call, bamboo cane, pat. When
Yes,
you
yes.
start,
Those are all like memories. The mistakes what we do in
Yeah,
previous
in
duty.
you know,
BTech I was
It
so
becomes
much.
my teacher used to say, show your right hand, okay? One pat she used to give, then show your left hand again.
Now beating to the students is very difficult. Parents will come and give.
Now it is against the policy, Taj. You're not supposed to hit.
Now the students will hit the teachers now.
One punch.
That is two kids 2.2 2.022
2.2 students now. Yeah.
That is how it is. In 80s and 90s and all, we used to give the hand. Okay.
Yeah, actually that one, that face was very good, okay?
Yes.
Okay, guys, after this slide, so we'll jump for lab now. Okay, the selection of the root port will be
As
depending.
we're not going to break.
Now I will give break after this slide. Okay, STP cost is accommodated total path cost based on the rates bandwidth. So remember, guys. So this thing is you have to remember in your brain. These are the cost form given by IEEE. So this is the old one. This is the old. Now this is the latest. For the 10 gig speed, the cost is 2. For 1 gig, the cost is 4. For 100 Mbps, 90. For 10 Mbps, 100. Means the lower the cost, okay, it is a better communication.
Taj, for the link speed, the cost should be higher, right?
Cost should be low.
On the logic behind, if it is a, say for example, I'm taking an ISP of around 40 Mbps, I'm paying 1,800 rupees. Since you're taking 500 Mbps, where you'll be paying around 2,500 rupees, because the higher the link speed or whatever the speed or whatever the
that cost is different because this cost is different.
Oh, this is different. Okay.
This is the link cost.
The link. Okay.
See, this is
link
the
cost means whatever we
see,
have,
and
we have
100
done the
Mbps
connection.
is
No, that
19
one,
and 10
Vikas.
Mbps is 100. Why?
see, as per this thing. So, example, this is my first. This is my 10 gig. Okay, this is my 1 gig, and this is my 100, and this is my 10. Okay, now maybe I think you are connecting here optical fiber cable here. Fiber optics.
Okay.
Fast.
Okay, the cost is 4. Cost is 2. You can see, right? The cost is 2 here. Now, here maybe you are connecting the another fiber optic with the speed it will support up to 1 gig. The cost is 4. Okay, for this guy, the cost is 90. Okay, this guy is, for this guy, cost is 100. Now, which is the best one?
First one.
10 gig.
10 gig means this is the one. This will become your root port.
Because the cost is less.
The cost is less because we are connecting by using the optical fiber cable by connector like SFP connectors. I have seen this one, guys. Because
What is that SFP connection?
I'll show you this. Diagram also I'll show you this. This is a connector like RJ45, right? I think you know, right? RJ45.
SFP connector. Okay.
Power RJ45 telsa meeku?
Yeah, I
sir?
know RJ45.
RJ45 ante emi?
RA45, sir.
RJ.
RJ.
J45. Like it is like a connector, sir. Connector or cable.
Yeah, connector like the LAN cable.
Yes, sir. Yes, sir.
Chusara, I think it is there with me. If you want me to show that one?
Yes, yes, sir.
I think not this one. Yeah. I think this is the connector, guys. Like if you see, this is RJ45 connector. You can see, right? And
I have available that connector, sir.
yeah, I think this is a LAN cable. This is we'll call the CAT cable.
Okay.
Category cable. And this one, what we are seeing here, and this is your RJ45.
Okay.
What I'm talking about here.
Hmm.
And RJ11 is for ఇలాగే ఉంటుంది కొంచెం తక్కువ ఉంటుంది సైజ్ గా దాని అది వచ్చి మీకు వీళ్ళు గోయింగ్ టు కనెక్ట్ ఫర్ యువర్ టెలిఫోన్ లైన్.
Okay.
Okay, today also all the words are ulta.
Where? On the screen?
Yeah.
No.
Yes.
For all?
But to
Hey, all is ulta.
me.
Yes.
Live,
Yes.
everything is ulta.
I don't know, man. Why is happening?
Only now available. Only selecting the root port page only available, sir.
Yeah, because root port is one which you can forward the new updates. Any changes in the network, only root port can send, not all the guys. Okay, this optical fiber cable, okay, we are going to connect based on your SFP connectors, not with these connectors. These two cables, how we are connecting by using your SFP connectors. This is optical fiber cable. I think we can see right at your home nowadays. Optical fiber is available for everywhere. Yeah.
Even from the Wi-Fi connections, given optical fiber only.
Yeah, the thin wire will
Thin
come.
wire it will be there.
Thin wire will be there. Yeah.
So this is how we are going to connect it. Okay, guys. So we'll do one thing. So we'll take break now for 15 minutes. Then we'll come back. We'll start doing your lab. Hello, guys. I'm back now.
Yes, that's.
Yeah. Okay.
So let me start the Cisco packet tracer. So we should do some basic labs.
Okay. Okay.
Okay, guys. So let's see in the switching, guys. Right now, I think these are the switches are available in your packet tracer. empty, and this is your multi-layer switch. And 35600, 3550. And this is the PCP switchboard. This is your bridge. This is another switch. So these are the switches are available in your receipt. So right now we'll not use any one of these switches, guys. I don't want to use these all RTP switches. So we'll use gigabit switches. These multi-layer switches we'll use. Okay, so right now we'll not use these all switches. We'll go one by one. Okay, right now I'm going to use this basic switching lab. Vikas and Sarik, you people are there, right?
Yes, Taj.
Yes, Taj, we are here only.
See, let's take automatic connection. Okay, so or else we can take manually also.
There is a lot of some distortions, Taj, from your end, I guess.
From my end,
Now it's clear, Taj. There was some interruption
Yeah, maybe I think in my home only.
in your home.
Yeah.
Okay. Some this thing that's good. Oh, sorry, Taj.
yeah. See, guys. So we can notice here one of these link is,
Down.
can you see?
Yes, one with amber color. There. One is up, another one is down. This
Okay,
is done by due to STP.
STP, spanning tree, due to the spanning tree protocol.
Yeah, where it blocks automatically blocks one link and only passes to another one.
Yeah.
In order to reduce the looping.
Okay, you know why you are connecting two links? Because you know what happened when you connect one link?
It will be high only.
It will be high.
Hmm.
Because you know there is no redundancy. You know,
Yes.
when links go down, okay, we cannot have the communication. Suppose you connect some pieces downside, and here also you connect some pieces. Okay, so what happened? There is no communication between them.
Hmm.
If these links go down,
Let's down only. Take some time.
correct? You can see
Nowadays.
it's totally depending on one link. What happened? Because you know it may go down at any moment. That's the reason, like, so redundancy link is quite very important. So even though you connected the two link, okay,
Hmm.
so by default your spanning tree is going to work, is going to block one of port, any
Yes.
one of this port. Now we need to check like which is our root bridge, which is the non-root bridge. How do I check this one? So let's say I'll open this switch, same like your router, guys. Just click here. Show IP VLAN brief, or as we can say show IP interface brief also, it will work here, no problem. Okay, the command is show spanning tree. Remember, guys, show spanning tree. So we can see the root ID. The priority is 32,768, but it's showing 769 because of the priority of the system ID is showing 769. By default, the priority is 768 plus one is this ID. Okay, the cost is 90, and this is the MAC address of this switch.
Hmm.
Right. So as we can see, how many ports we have connected? Totally
6.
6 ports. 6 ports we have connected. So we can see port number 1. Okay, port number 1. Okay, we can see it is the
Root.
port. Port number 6.
Alternate.
Alternate or backup link. The
Backup.
cost is 90. all are into forwarding state. Okay, because I have not labeled it. So let's label this, go to preference, show all port labels. Now we can see, right? So which all the ports are available, which all the ports are active. And this is how we can see here, which is a, now he's not showing who is the root bridge. So remember guys, this is the VLAN 0. How to check? Show VLAN brief. It will show you what are the VLANs it is running in the switch. So right now we have not created any VLANs. This is the VLAN information. We don't have any VLAN.
Yes.
Remember guys, so these things, what I'm trying to explain here, this is, we'll call it as your native VLAN. Native VLAN. And this in where it is a active, status is active. So these are the ports are available in your native VLAN, in this VLAN. So how many? 24 ports. So 24 ports plus 2 gigabytes ports. Gigabytes 1 and gigabytes 2.
For broadcast and multicast. Right?
Yeah, that is all for broadcast and multicast. And this is for FDDI token ring default multicast. So this we are not using it. So this is the VLAN 1 is called your native VLAN. Remember this. Native VLAN. By default, you cannot delete this native VLAN. Remember it. Okay, you cannot delete your native VLAN. After this, once you create the VLANs, okay, that is a VLAN means virtual VLAN. Okay, that will do it the lab later, no, not now. So now you tell me then who is the root bridge? Let's check with this router now. Sorry, this switch now. Now we are dealing with only switches. Show spanning tree. We can see this bridge is root. Got it. All ports are into forwarding state. We can say, right? What about this switch? Previously, what command? There is no information about the root bridge. Okay, this is the root bridge. Got it, guys? This is the root bridge now. Got it. And other switch, this is your non-root bridge. Then how do I change that one? Can I make changes? So right now, so example, let's say I can go to global configuration mode. This is my switch 2. Okay, and this is my switch 1. This is my switch 1. So now this guy is not show span. Means show spanning tree. And this is not a root bridge. We can see one link is down. Can you see? Okay, what I will do means I'll make it one link down. How do I make? Like interface Fortinet 0/ I think 6.
Shut down.
Shut down. Because we have made shutdown for the wrong interface. Right. So I say no shut. We have to do the shutdown for because let me remove this label because it's showing not showing the label. So I think now we can.
But you can make it bigger. That's that would be easy.
Yeah. Now it is better, right?
Now it is better. Or no, we can label it as.
Yeah. So what I'm going to do now, so I will make it. This is my road bridge. So I'll disable these. Which interface? I think one. I'll make it down. Fortinet 0/1 shutdown. Okay. So now if we type show spanning tree, so we can see who is listening and learning. It will show you. Check this router now. Show span. See, he's learning, right? Can you see? He's learning, still is learning. See, now it has become forwarding. Now these guys come up, right? Automatically. Means just have make it, this link is down. Okay, what happens if I make that link is up again? So go to global interface 0/1, no shutdown. So now you see show span. She's listening, right? LSN means listening. Again,
Yes,
it will
thanks.
come now. It will come learning. Can you see now? It is learning now. Show spanning tree. So it takes long time. How much time it takes? See, now it is come up. You can see, right? It has become the green color.
Raj, can you explain this once again? I'm sorry.
That's for me also. Then.
See, what is this, guys? What I'm trying to explain.
No, this commands and all you wrote, no, right? That complete thing once again, so that I'll just be very clear. So
See, right now, this is the blocked. Why it is blocked? Because by default, your spanning tree is running on the both the switches, spanning tree protocol. So here also you are running your spanning tree protocol. So what I did, okay, so if you make this link down, if you make this switch down, so what happened? So this will come up, right? To come up this, okay, for blocking, it take 20 seconds. For listening, 15 seconds. Okay, and learning, again 15 seconds. It's totally 50 seconds. That's the reason we can see here. Previously, what I showed to you. So it was listening, learning, right? You can see here. See, previously it was listening here. Here also learning. Here also learning. Here also learning. Here also learning. After 50 seconds, it will become forwarding state. It will come up. So let's do that, guys. What I'm going to do now, so I will shut down this link. So there's the link name for this one is, guys, this is Fortinet 0/1. Okay, means this interface. This interface. Okay. So what I'm going to do here, so go to global configuration mode, interface Fortinet 0/1. I say no shutdown. Exit, show spanning tree. not these switches, check for these switches now. Router 1. Show span. So we can see is listening. This link will come up. Now it is listening. Now it is
Yes,
listening.
yes.
This link will still is listening, taking time. Show spanning tree. Yeah, now it is getting forwarding. This will come down. If you make it up again, go to the interface, I say no shut. Then show span. So now this guy will come up now again. And this port will become your root port. Still it is listening. Now it is learning. It will take another 15 seconds. Then it will become forwarding. Still it is in forwarding mode. Yeah, so now it is into forwarding. Very simple. I'm not doing any configuration. You understood, guys, what I'm trying to explain? And this is the root
Yes,
bridge.
yes, Taj.
This is the root bridge. What if I want to make this guy as a root bridge? How I can do it? I want to make, okay, right now, this guy is a root bridge, right?
Yes.
This is the root bridge. And this is your non-root bridge. This is your non-root bridge. So now how I can do it? I want to make this is the root bridge. And this guy, I should be the non-root bridge. So how I can do this? First tell me, it is possible or not? Can I make it this guy as a root bridge? Can this guy, can we do the non-root bridge?
It's possible that.
Yes, it is possible, guys. We can make this guy
Possible.
root bridge and this guy as your non-root.
Non-root bridge.
It is possible. We can do that. No problem.
By manually assigning the numbers.
Yeah.
That 34096 or something. Okay.
Okay. How? I think Vikas telling something. Yes, Vikas.
No. As you said before, so while giving a theoretical part, they are explaining the theoretical.
Yes.
That 4096 that we
Span-
can assign it manually.
Yeah, we can, because we can change that bridge number, no?
That's what manually we have to assign it.
We have to reduce it.
Yes. So spanning tree mode also we can change that. We shall discuss later. PVST RSTP. So spanning tree. VLAN 1. Okay. Decent priority. So we can see, I told you, right? So it will be incremental value of 4096. Okay, for the VLAN 1. Right now, we have not created any VLAN. So now, right now, we are dealing with the only native VLAN. So we can give this value 4096. Now the link is coming down, right? Can you see? What happened now? Then show spanning tree. Now this guy is learning. So now this guy, can you see? This guy became the root bridge now. Listening, learning, still is learning. Let's see, guys. So we can see, right? We can see. So this guy became your root bridge now. And this guy will become your non-root bridge. You can see, right? It's showing here. Here, guys, you can see. I'll use all the colors. Right now, we are using these interfaces. Then how do I check? What about this switch now? Let's see. Show spanning tree. And this guy will become non-root bridge now. It's not showing, right? VLAN 1. Spanning tree enable protocol IEEE. It's running on default. See, we have changed, right? Priority to 4096, right? And one is this one. That's the reason. So this is not become your non-root bridge. Root bridge is this guy. The priority is this. Same like, and this one also we can make it this one priority. Oh. I think someone has written here.
No, you only touch when you take something out, it just got some scratches now.
No, man.
That blue color one, right?
Yes, yes.
Oh, that you know when
Hey,
you are
no, blue color one. I wrote that time. Actually, what happened was I was changing this one. It suddenly came a blue color.
No, there is a setting is there in Zoom. I think for you people, I should not allow you to access my pen. Okay. See, now we can see this also we can make it another spanning tree for the VLAN 1. The priority is 4096. Now this guy will become my again root bridge. You can see. Understood, guys? Okay. So now what I will do, guys? You want this file, guys? This lab you want me to send?
Just touch, or else only the commands should be great. It's okay, sir. You send it across this.
Okay, so let me create the folder here. I think commands are very less here. I think, okay, so let me open the new file now. Okay, you can check from your side, guys. I'll share you these two files. Okay, so let's me do now another lab now. So this time I will use 3 routers and I will connect all the 3 routers. Okay, now you have to tell me, guys, who is the root bridge and who is not the root bridge now. So let's come up fast this one. Okay, so now we can see all links are up now. All links are up. So let's check who is the root bridge first. So configure, and this is my, sorry, switch 1. Show spanning tree. Okay, this guy is not a root bridge. You can see, right? Because out of 4 links, okay, only one link is forwarding. Right? We can see, right? Only one link is forwarding this side. So only this link is into forwarding state. So let's check with this guy now. Show spanning tree. Yeah, so this guy is the root bridge. So on what basis he has selected, guys? Based on the highest MAC address or lowest MAC address?
Lowest MAC address.
0217993C, right? So does it look like same? 71 AC and this 71
Yes.
AC.
Lowest MAC address types.
Lowest MAC address? Is it look like all the same MAC address same?
Yes.
002.179C, 71 AC. And this one also 02170. And this guy also this one. Then how come this guy is the root bridge now? On what basis this guy has selected?
The forwarded delay, it's around some 15 seconds it's mentioned. The time taken, it's very less. No, you said touch before I just made a note.
Yeah, no problem. See, understand, because right now we are using the packet tracer, the software based. Okay, so we are we have repeated the same switch 3 times. Got it. So the same switches MAC address are same, right?
Oh.
Now on what basis they have selected? So this is the root bridge, right? This switch is your root bridge. And this is your non-root bridge. And this guy also your non-root bridge. On what basis he has selected? And this is the root bridge now, because all links are up now. And here one link is blocked. Here 3 links are blocked. Only one link will, this will deactivate. One link is active. All 3 links are blocked here. Then how it is showing that? How, on what basis this guy has selected the root bridge? The question is this.
Aging time.
Aging time?
No.
We will take one more scenario. So I will take different switch this time. Let's see what happens. One and PT switch, and this I'll use 2950 and 2950T. So let's connect these guys. Make it fast, increase this one, it will come up fast. So now we can see, again, this guy has become root bridge on this side. Let's check with these guys. Enable show spanning tree. See, these guys, MAC address is, say example, this is a DB and this is not a root bridge. Right, so this is not a root bridge. Okay, let's check with this guy. So you want me to increase this size? It's a look like pyramids. Show spanning tree. So this guy has become the root bridge. That C7E2 500. Sorry, 5DIDA. Does it look like same MAC address, guys, here also? Is same MAC address? And what about this guy? Same MAC address.
Yes, that's.
It is same, right?
Hmm.
Then why this guy become the root bridge now?
Taj,
Hmm.
I am also full confused, Taj.
No, I'm asking question, guys. I know that.
I understood. No. Because both the things are three links are down, no, Taj.
Hmm.
3 or 4.
Yeah.
4
See.
links are blocked.
So here, in this switch, all 3 links are down.
Correct.
Okay. Here, 1 link is down. So in this switch, all 4 links are up. MAC address look like same. Means it has given the election process happened based on the cost, not based on the MAC address. When I on this switch, when I connect it to each other, so when all the BPD will send, right?
Yes, that's BPD.
BPD will send to every link. So BPDU. Every 2 seconds it will send. So BPD, what it contains? It contains your bridge ID. Bridge ID plus MAC address. It will send his MAC. Okay, the bridge ID also same. What is the bridge ID? 32,768. This is same for all, right? 32,768. Here
Yes.
also 32,768. Now, here in this scenario, the MAC address also same, the bridge ID also same. Now, only option left is cost. The cost he has taken, of course, we are connecting with the same link. Okay, so we will take any one of the link because there is no option left for us. We are not getting any option for them. So that's the reason. So I want to become the root bridge later on, as per your requirement. In case you want to make this switch as a root bridge, you can make it manually by setting your priority to 4096, which we did. Understood, guys? So let's do that. So let's say I'll go to this switch now. I can make it, right? How to make it, guys? Sorry, can you tell me? I want to make this switch as a root bridge. Right now, he is not a root bridge. Show spanning tree. See, he is not a root bridge.
Yeah, we have to reduce the root ID, Taj. Root
Okay,
ID, priority ID, we have to reduce it. Right?
Okay, how I can do it?
Spanning root.
Okay. Spanning tree.
spanning tree, root
VLAN,
VLAN
1,
1. Oh,
priority
4096.
4096.
Okay.
That's it. So now we can see and show span. So now this guy has become the root bridge.
Yes.
It's a very simple lab, guys. Okay, you want me to share this one? I think not required, guys. Just to connect from your this thing in the packet tracer. So automatically your span tree is going to work. So now in the same one, I will take one more by using your multi-layer switches. So here I am going to connect these guys. I can also connect this way. Okay, I can also connect this way. Very good design, no? So, okay, some links are coming up now. Okay, so now all the people are coming now. This is your multi-layer switches, guys. So let's check this now. Who is the root bridge? I guess this is the root bridge. Because when the all links are up now, you have to imagine that, you have to understand that. So this is our root bridge. Shows spanning tree. Yes, you can see, right? This is our root bridge. So is it look like your mesh topology, right?
Yes, sir. Yeah.
Okay. So in the network architecture, guys, so most in the main in your layer 1, layer 2, layer 3, so they will connect based on the mesh topology for redundancy. That's the reason I have given this connection. So each switch is connected to each one directly, right? You can see, right? So each switch, say example, this is my root bridge. So this is my root bridge. Okay, it is connected to this switch. It also connected directly to this switch. It also connected to this switch. Okay, so same like, so this switch also connected to directly to this and this also. And everyone switches, say example, this switch also connected to this directly, this and this. Means this is, we'll call it as your mesh topology. So as I told you that this is our root bridge, right? So which is our root bridge? This is our root bridge. This is our root bridge. And as usual, you can select any one of your guy, you can make it as your root bridge. Okay, so now suppose if you see there's a command like configure, if you want to make a spanning tree port fast, also we can make it. The moment you have given port fast, it will become port fast for BPD guard default by default. The moment you connect any switch, say example, if I connect any router to this switch, so immediately it will come up. It doesn't take much time because it's a router. So let's say I will connect switch now.
लेकिन we did not do any changes for this, no, Sajbhai.
Yeah, we are not doing any changes. I don't know what to do now because already explained, right?
No, I understood. So what I'm saying is now for this multi-layer one only the left side one, top one, left. This one is the main bridge, right?
Yeah, root bridge, yeah.
Root
This
bridge
one.
for the,
Yeah.
that one. Because it is all the links are connected.
Okay. Yes.
So now my question is one small question. Now in case this is 3-layer, matlab three multi-layer ones which is there, that time how is it?
Same procedure, no difference.
The first one, whatever we did.
Yes, same thing. You can select, suppose an example, I want to make this guy as a root bridge. We can make it. You want to make it. Say example, in this scenario, I want to make this guy as my root bridge.
So I can just go and configure the same thing and put it 4096.
That's it.
Okay.
That's it. Nothing else. Same thing command. If
And
not,
this is if it is like this multi means this is all like mesh topology, whatever we are seeing.
Same. Topology might be anything. Your mesh topology, star topology, or ring topology doesn't matter.
Okay.
So because we can make it. Say example like I will go to global configuration mode, spanning tree VLAN 1. The priority that is 4096.
4096.
So spanning tree. See, this guy became the root bridge now.
Okay, and now that one already one link is down for that one. First one, see.
See, it is coming down now. Now this will come up now. You can see, right? This link will come up.
Correct. It will come up, yeah.
Yeah, see, learning still is learning. Still it is learning.
Yes.
Yeah, it's come up,
all
right?
the links are up. Yeah.
Now it is come up, right?
Correct.
Yeah. We'll do this lab, guys.
Which one, touch?
This list of this lab. It's quite very easy.
Yeah, it's easy.
Okay. So let me go for this lab now. Okay, I'll open this guy. Show VLANs. So right now we don't have any VLAN which we have not yet created any VLAN. So what is a VLAN means? Virtual VLANs. Okay, we are dividing your physical switches to virtual switches. So how to create a VLAN here? Just VLAN 10. Okay, so name I can give. This is my say example HR VLAN. Okay, also I can create VLAN 20. So name I can give network security. Security VLAN. That's it. So show VLAN brief. So we can see, right? So we have created two VLANs here, VLAN 10 and 20. Okay, guys. So now we can see now there is no ports connected here. Now ports are empty. All ports are available in your VLAN 1. That is your native VLAN. For all the switches, by default, it is available in your VLAN 1. So I want to add some ports into your VLAN, HR VLAN and network security VLAN. Okay, so how do I add this? So go to global configuration mode. So interface range. So let's say what I want to do to first understand. So this fast Ethernet, let's say this fast Ethernet 1 to 4 ports. These 4 ports I want to assign for VLAN, HR VLAN. Okay, and these VLAN
Two networks.
Like
5
6,
to
7,
8, I want to
7, 8.
I want to assign for security VLAN. Got it? So now all these ports are available here after we assign that. Okay, right now they are empty, right?
Yes.
They are empty now. They are empty now. So what I am going to do now? This is what it is. I will take the range. Okay, interface range fast Ethernet 0/1 to 4. Okay, then switch port mode. These are the access ports. Okay, these are the access port. Switch port access for the which VLAN? VLAN 10. Understood, guys? Now, same thing, exit from here, then repeat the same command. And from here, 5 to
8.
okay, 5 to 8. Okay, switch port mode access, switch port access, VLAN 20. That's it. Then show VLANs. We got it right? Can you see?
Yes, yes, that.
These all switches. Got it. It is assigned to these ports. Mismatch. Understood, right?
Yes, yes, that.
Okay. So let's connect some pieces here. I will say, let me take some
Vikas,
pieces.
are you there?
Yes. Yes.
Everyone is there, guys, bro.
Why, man? You want me to stop today, or shall I continue?
No, no, continue.
No,
Yeah,
no,
you
sir.
can
Continue. Continue.
Okay, so right now I have connected. I don't know which is the interface for this one. Let's see which interface I have connected. So I want to connect to the specific. So I want to connect to the specific interface. So, you know, right? So 5, 6, 7, 8 is belongs to which one? For the VLAN
HR
20.
2020. Yeah.
Okay. Now same thing here. I think 1, 2, 3 is already assigned. I think let me take this auto. Let me see the label, like which interface is connected to whom. Wrongly it is assigned. So I think 5 and 6. So I don't want to give connection like this. I want the connections as per my requirement. How I can do that? I want to connect manually. Okay, see 5, 6, 7, 8 belongs to VLAN 20, but it's not showing that 1, 2, 3, 4, 5. Right? And there is a mismatch for VLAN. Something is showing error here. Show VLANs. See 1, 2, 3, 4 is not showing. Okay, so we have to remove that. How do I remove? Okay, that interface, fast Ethernet, interface range, fast Ethernet 0/1 to 4. Okay, no switch port mode access. It is in, must be configured as a trunk link. Okay. So what mistake I did, guys? Actually, the two interface, 1 and 2, which is connected for this interface. So why these two? This is fast Ethernet 2 and this is 1. So this is my fast Ethernet 1 and 2, which is connected my to this is 2. Okay, this switch I cannot assign for VLANs. Remember, because I had to make this as a trunk link. This I'll discuss tomorrow, guys, not today. So this one is asking, because this all we'll call it as your trunk link. This all we'll call it as your trunk link. So what I can do, I can remove that and we'll do right from the scratch now. The reason is showing mismatch. So I can do write, erase, reload. So you want configure system has been modified. Save? No. Don't save. So meanwhile, what I will do, so let's take this switch now. Or else I can go for new first switches just to avoid the confusion, guys. Maybe I think you'll get confused. So yes, I'll save this file. This is switch lab 2. Very simple lab. I will go 1, 2, 3, 4. Okay, so right now I'll use only these 3 switches. So let's connect these guys. So previously, I think we are supposed to give this basic connection, right? So let's check this one. Show spanning, because there's no spanning running, because it's a route itself, because there's no spanning tree will work when you connect 2 switches. Right now, this
here only one switch is there. No?
One switches. There's no election process happening now. So now what I'm going to do, so now I'll create some VLANs here. Say VLAN 10, name I will give HR, okay, and VLAN 20. Okay, name I will give cyber security. So now what I'm trying to explain here. So now I want to divide this network. So these 2 PC belongs to my VLAN 10. Okay, and these 2 PC are belongs to my VLAN 20. Okay, so this is what I want to explain you that. So this is my VLAN 10 and this is my VLAN 20. So right now we have created. So do show VLAN. So right now we have created the 2 VLANs. So what I'm going to do, so first 4 ports I'll assign for the HR VLAN, and 5 to 8 ports I'll assign for your cyber security VLAN. Same command. So interface range fast Ethernet 0/1. So this time will not get that error. Okay, make it. This is the
because it's got only one switch.
Yeah, one switch. Switch port mode access, switch port access for the VLAN 10. That's it.
Okay.
And same thing for other range. So here start from 5 to
8.
5 to 8. Okay, switch port mode access, switch port access, VLAN 20. Here, show IP interface brief.
No, Taj, VLAN.
Show VLAN. Right, now they have been assigned. Okay, so let's give IP address for this PC. Can they communicate? Say I'll give the range of 192.168.1.2. 192.168.1.1. So gateway will put same for all. And this guy is 3. Gateway is same. And can they communicate, guys?
Just touch.
Can they
Because
communicate?
they are directly connected, right?
Okay. Can we ping now?
Yes.
Okay, so let's ping to this.
Yeah, all is successful.
Okay, all people are communicating to each other. Fine. Okay. So now, because it is which are the ports we are connected? 1, 2, 3, 4. Correct. You can see, right? This is sorry. So this PC is connected for 4, and this is connected for 3. You can see the label, right, on the switch.
Yeah.
You can see the label, right? 3, and this is 2, and this is 1. Fine. So now what I will do, I'll delete this link. Okay, I will connect manually. This time I will select. This time I select 5. Okay, I will select 5 and 6. Okay. Can they communicate now?
Yes, Taj, because already we have given the IP address, no?
Okay, let's check. Ping to this. No.
No, now we change, no, Taj, we have to give the IP address again, no?
Already then IP address is there. See, IP address is there here already for all the PCs. We have given
why is
already.
it
Even though if we don't give IP address also, it should communicate because via switch it's directly connected, right?
Yeah, but now it has failed, no?
He have changed something, no? That
No,
fast is
he just changed the fast
zero
Ethernet.
and 5. That is not been assigned, no. So see, 0 to 4 it's assigned to VLAN 10, and
Yeah.
5 to 8 it has been assigned to VLAN 20.
Correct.
But whereas he have changed that.
2 VLANs, it is 2 different VLANs now.
Okay.
Now it should communicate from VLAN 20 to VLAN 10.
Yes. Exactly.
But why it is not communicating yet? But they will communicate to each other. This same thing. They will communicate.
Because they are in the same VLAN, no, Taj.
It's like a virtual network, right?
But why it is not communicating these two?
They are 2 different this one, no, Taj.
Yes, they belongs to 2 different VLANs.
Different.
2 different VLANs, VLAN 10 and VLAN 20.
See,
like a virtual network.
Yeah. Yes. See what I did. Okay, I have created 2 VLANs here. That is
There
VLAN
are
10
2 different
and VLAN 20. So where I have connected the 2 PC here and 2 PC here. And 2 PC I have connected here. And IP address what I have given? This 1.2, 1.3, 1.4 and 1.5. So even though it is connected to directly connected to the same switch, okay, previously it was getting communicate to each other, right? Once we create
already partition is made, no?
Sorry, thank you.
See, already we have done the VLAN, we have created the VLAN, virtual VLAN. Okay, even though belongs to the same network, still they cannot communicate. That is the advantage of your VLAN. We can create the VLANs here. That's what I supposed to explain.
But can we do that? Can we communicate between two VLANs?
Yes, we can.
How would that touch?
That we can do inter-VLAN routing. I think it is there, right? Inter-VLAN routing. I think in the notepad, I think today morning, I think I explained it. Right, you can see, right, inter-VLAN routing.
Okay.
We can do that. Slowly we'll go, guys.
Yeah, sure.
Right now we are up to here. I explained regarding the trunk link. Also, I'll explain tomorrow. I'll explain.
Tomorrow we're doing trunking, no?
Yeah, tomorrow we'll do the trunking. Understood, guys, right? All of you?
Yes.
Okay. So please practice, guys, because in coming sessions, a lot of things I want to explain. Okay. So can we see that tomorrow?
Yeah. Attach, save this one and send, no?
You want me to send, you want me to send this one as well?
Yeah, save this one.
Yeah. So let me send you that. This is switching lab, basic lab 3. And commands also you want, right?
That time also, the 2 also you have not sent touch. 1, 2, and 3.
Okay. This is for 3.t. Let's see. Two, did I send you guys? 2?
No.
No touch.
Okay, I'm sending all, guys. Once again, I'm sending you all.
Basic switching and basic lab 3 you have sent. Lab 2 is having.
Lab 2 is there.
Yeah, touch you have sent. Lab 2, lab 3. Now desk.
Yeah, all 3 I sent it at a time.
At a time, yes. Oh, one by one it's coming.
Okay, guys, then see you tomorrow.